Suppose a plus b plus c equals to pi, where a, b and c are the vertices of a triangle. We need to show that sine of a plus sine of b minus sine of c, that's equals to 4 times the product of sine of the half angle a over 2, sine of the half of the angle b over 2, and cosine of the half angle c over 2. Okay, let us begin. Now here, this particular problem is a case of a conditional trig identity, meaning let's say we start by considering an identity sine squared theta added to cosine squared theta equals to 1. Now this is a standard trig identity. That's because this identity is going to be true, whereas this particular equation is going to be true for any values of theta that we choose. However, in the case of this identity, this is going to be true only for fixed values of a, b and c. That means we can take only those values of a, b and c such that the sum equals pi radian. That's why it's referred to as a conditional trig identity. So to prove this, what we'll do, we'll begin from the left hand side and we'll show that it is the same as the right hand side. So here on the left hand side we have sine of angle a added to sine of angle b minus sine of angle c. So here what we'll do, we're going to add the first two sine function, because here we know there's a standard formula. So if we have sine of angle c added to sine of angle d, this is given by 2 times the sine of angle c plus d over 2 multiplied to cosine of the angle c minus d over 2. Fine. So here what we'll do, we can consider a to be equivalent to c and b to be equivalent to d, and that's going to give us 2 times sine of the angle a plus b divided by 2 multiplied to cosine of the angle a minus b over 2 minus sine of angle c. Now what we can do is we can work with sine of a plus b over 2. We can actually simplify this. So let's try to understand how. So here what we will do, that we have sine of angle a plus b over 2, but we're going to make use of the fact that a plus b plus c equals to pi. So we can replace the numerator a plus b simply with pi minus c. So we have pi minus c over 2. But now what we have is sine of pi over 2 minus c over 2. And we know for a fact the sine of pi over 2 minus some angle theta, the sign changes to cosine and we get cosine of that angle c over 2. Now in other words, we are saying the sine of a plus b over 2 is the same as cosine of c over 2. So coming back to our equation, so we have 2 times, so in place of sine a plus b over 2, we have 2 times cosine of c over 2 multiplied to cosine of a minus b divided by 2 minus, now we have sine c. So here there's a standard formula for changing sine c to a half angle. So that means here we will have 2 times sine of c over 2 multiplied to cosine of c over 2. Again here we have a standard formula, so let us note it down. Since sine of angle theta equals to 2 times sine of angle theta over 2 multiplied to cosine of theta over 2. In our case, theta is actually c. Now why did we make this transformation? Because in doing so, we can see here that we can take 2 times cosine c over 2 as the common factor, and we need cosine c over 2. So this is going to be extremely helpful. Now what we'll do, we're going to take 2 times cosine of the angle c over 2 as the common factor from both of the two terms. So the first term is going to be cosine of a minus b divided by 2. And then in the second term, we have negative sine c over 2. Now we can actually change sine c over 2 as well. So let's try to understand how we do that. So we have sine c over 2. Now in place of c, what we can do, we can rewrite it as pi minus a plus b whole divided by 2. Or in other words, we have sine of the angle pi over 2 minus the angle a plus b over 2. Now sine pi over 2 minus theta, that's equals to cosine of theta. That means cosine of a plus b over 2. Our expression now becomes 2 times cosine of the angle c over 2 multiplied to cosine of the angle a minus b divided by 2 minus cosine of the angle a plus b divided by 2. Now what we have is a difference of two cosine function. Now we have a standard formula. We know that cosine of angle C minus cosine of angle D. So that is given by 2 times sine of angle D plus C over 2 multiplied to sine of angle D minus C over 2. So here we are going to assume C corresponds to A minus B over 2 and D corresponds to A plus B over 2. So using this, we can make the transformation. Now we have 2 times cosine of angle C over 2. So cosine of some angle A minus B over 2 minus cosine of another angle, which is A plus B over 2, is simply going to be 2 times sine of, so what we need is D plus C over 2. Now D is A plus B over 2 and C is A minus B over 2. So when we add both of them, let's do that. A plus B over 2, this is D, added to A minus B over 2 whole divided by 2. And then this is going to get multiplied to sine of D minus C over 2. That means we have A plus B over 2 minus A minus B whole divided by 2. So let's further simplify. This is now going to give us 2 times cosine of angle C over 2 multiplied to 2 times sine of angle. Now A plus B over 2 added to A minus B over 2, that leaves us with positive A. So we are going to be left with A over 2 finally. And then similarly this is going to give us B over 2, which means we now have 2 times 2 multiplied to 4. Rewriting the terms, we have sine A over 2 multiplied to sine B over 2 equals to multiplied to cosine of C over 2, which is exactly the expression on the right hand side. So what we have done is, thus we have successfully showed that if we have sine of angle A added to sine of angle B minus sine of angle C, so this is going to be equals to 4 times sine of angle A over 2 multiplied to sine of angle B over 2 multiplied to cosine of C over 2 4. And this is going to be only true if we have A plus B plus C equals to pi radians, hence proved.